Hello everyone, I'm Han Song, and let's do the homework 10 of the first question. In the first question, it requires us to find for a Poisson process. It requires us to find the expectation of xt, and b is the autocorrelation of t1 and t2. And let's first do a. As we have known that for some distribution, x of k equals to e to minus lambda times lambda k over k. And so we can get that from n equals 0 to infinity of e to minus lambda times lambda 2k over k, it will equals to 1. And this, according to this, we can get that times e to lambda of both sides, we can get that lambda 2k over k will equals to e to lambda. And we can derivate both sides of lambda. We can get that n equals 0 to infinity of lambda to k over k d lambda will equals to this one will after derivation will also equals to e to lambda. And we can do the calculation, get that this one will become lambda times lambda 2k minus 1 over k, and equals to e to lambda. Oh, sorry, it's a k. And we can multiply lambda on both sides. We can get k times lambda over k equals lambda times e to lambda. And we can multiply e to minus lambda on both sides, and we can get this result, k times e to lambda. Sorry, there's a k. Lambda 2k over k equals to lambda. And since this one is equals to e of x for some distribution, so e of x will equals to lambda. And again, for the variance, we can get that since according to this one, n equals 0 to infinity of k times lambda k minus 1 over k equals to e lambda. And we can again derivate of both sides, and we can derivate on both sides of lambda. This one will also equals e to lambda, and this one will become n equals infinity 0 to infinity k squared times lambda to k we can use this one. So there is k, and here is lambda. And so this one, do the derivation of lambda will equals to e to lambda plus lambda times e to lambda, and this one will become k square times lambda of k minus 1 over k over k will equals to this one, and times lambda on both sides. We can get this equation, and times e to minus lambda on both sides. We can get this result. Since this one is the variance, so we can get that for some distribution, the variance is equal to lambda plus lambda plus lambda. Oh, sorry. This one is equal to e of x squared, and it will equals to lambda plus lambda squared. So for the variance is equals to e of x minus this one square, and equals to e of x squared minus the mean square, and this one is equal to this one equals lambda plus lambda square, and this one is lambda square, so it is lambda. We can get the variance, and so we can get that since e of x is equal to lambda, so e of xt will equals to lambda t. And next, let's do r of t1 t2 equals e of x t1 times x t2, and this will equal to e of x t1 times x of t1 plus x of t2 minus x of t1, and this will equals to e of x t1 square plus e of x t1 times x t2 minus x t1. Since 0 to t1 and t1 to t2 are non-overlapping, so we can know that x of t1 and x t2 minus x t1 are independent, so this one equals to e of x of t1 squared plus e of x t1 times e of x t2 minus x t1. and this one is equals to lambda square t1 square, and this one is equals to lambda t1, and this one is equals to lambda t2 minus t1. And after some calculation, we can get the final result is lambda t1 plus lambda square t1 t2. And in this case, we assume t2 is larger than t1. And if we do the case of t1 is smaller than t1 is larger than t2, we can get a similar result. The similar result is lambda times t2 plus lambda square t1 t2. So overall, we can get a final result of r t1 t2 equals lambda times the minimum of t1 t2 plus lambda squared t1 t2.